The Higgs boson is a hypothetical massive elementary particle predicted to exist by the Standard Model of particle physics. The existence of the particle is postulated to resolve inconsistencies in theoretical physics, and attempts are being made to find the particle by experiment, using the Large Hadron Collider (LHC) at CERN and the Tevatron at Fermilab. The Higgs boson is the only standard model particle that has not been observed in particle physics experiments. It is a consequence of the so-called Higgs mechanism, which is a part of the standard model that explains how most of the known elementary particles become massive. For example, the Higgs boson would explain the difference between the massless photon, which mediates electromagnetism, and the massive W and Z bosons, which mediate the weak force. If the Higgs boson exists, it is an integral and pervasive component of the material world. If it exists, it is of a class of particles known as scalar bosons. Bosons have integer spin and scalar bosons have spin 0. The photon is a kind of boson, and so is the less familiar gluon, along with the W and Z particles mentioned above. These particles are all vector bosons, with spin 1. That present there are no known elementary scalar bosons in nature, although many composite spin 0 particles are known. Theories exist that do not anticipate the Higgs boson, described elsewhere as Higgsless models. Some arguments suggest that any mechanism which generates the masses of the elementary particles must be visible below 1.4 TeV. Therefore, the Large Hadron Collider is expected to provide experimental evidence of the existence or non-existence of the Higgs boson. Experiments at Fermilab also continue previous attempts at detection, albeit hindered by the lower energy of the Tevatron accelerator, although it theoretically has the necessary energy to produce the Higgs boson.